To solve problem 1, part 1, section A, which is show that theta, this angle here from the perspective of the viewer in the cinema, equals to the arctangent of 28 over x minus the arctangent of 6 over x. So the first thing we need to do is obviously simplify this diagram. So mainly what we do is subtract 4 feet from both sides of the screen. In this case, we essentially reduce all the height of the viewer, and we also subtract 4 feet from this side of the screen. And so now we are left with this simple diagram. Remember, this is x, and there is still a limit of 7 feet, although that's not important for our calculation right now, so it's no necessity to write it down. So, clearly the tangent of gamma equals to 6 over x, since tangent equals the opposite side over the adjacent side. So, gamma must be equal to the arctangent of 6 over x. We also need to take into account that there's a big rectangle triangle between theta and gamma, which would be the one with 22 feet plus 6 feet over x. So to make the part B of part 1 of problem 1, we need to show that arctangent of 22x over x squared plus 168 equals the arctangent of 28 over x minus the arctangent of 6 over x, which is the equation that we got originally in part A of our demonstration. So to do that, we are going to be using the tangent subtraction identity, which is the following one. Arctangent of a number minus the arctangent of another number equals the arctangent of that same number minus the other number over 1 plus 1 times the other one. So in this case, the first number would be 28 over x, and the second number would be 6 over x. So we substitute directly the values in this one. Now, we should remember that this part of the equation equals theta. That's what this equation represents, theta. So we can substitute that part, so theta equals the arctangent of 28 over x minus 6 over x over 1 plus 28 over x times 6 over x. So, to solve this, we first simplify this part by subtraction, then we multiply these two, and the 1 we substitute it for x squared over x squared, then we join it all together. So, as our last part to solve the problem, we need to show the maximum value of theta as the function of x, which, as you might remember, we already discovered in the part C of this problem. So what we first do is separate this function into two parts. First, the arctangent part, and then the polynomial inside, which we will name m of x. Now, to find the maximum range of this function, we want to get the inverse function and then get the limit of the domain of that inverse function. But if you remember, the domain of the inverse function is the range of the original function. So we first get the inverse function, but we do that by first solving this equation through the quadratic equation, and then we get this expression. And to get the limit of the domain of this expression, we need to notice that it has a square root. As you might remember, square roots cannot hold negative numbers inside, which means the smallest possible value inside the square root is 0, which means 484 minus 672 x squared cannot be smaller than 0, which means the limit of the domain of this function is whatever value sets this expression to 0, which is what we do just right here. And so then by solving this equation, we get this final result, which is x equals to 11 times the square root of 42 over 84. Now that we got the limit of the range of m of x, we will then integrate it with g of x, since they are co-functions with f of x. And so we do so, and then we unite them, and then we get this expression. So this means the limit of the range of f of x is the arctangent of the limit of the range of m of x, which is this expression. And so as our final answer, we 40.32 degrees approximately, or 0.703 radians. To get the distance between the screen and the spectator, we then introduce this value here in the original inverse function. Why? We do that because now that we know the limit of the domain of this function, if we get also the range or the value of y in this function, then that is the distance. Because of course, the graphs that we are using compare angles versus distances. So we introduce this value here. If you wonder why we don't have the square root with all of this, you must remember this value is designed to make the square root become 0. So if the square root is 0, then we don't really need to write it down. It's redundant. So we write down the answer, we solve it, and then we get the answer of 2 times the square root of 42, which is more or less 13 feet, which means it must be the second seat from front to back. Why? Because the first seat is 10 feet away of the screen, and the second one is 13 feet away of the screen. Since each seat is 3 feet between each other, and the first seat is 3 feet behind the limit of the floor, which is 7 feet away. So 3 plus 7 is 10, plus 3, 13, which is fairly close to 2 square root of 2.
Hi, this is the second part of the problem Where to See at the Cinema, and this is the data that the problem shows us. And the problem also makes some statement of how we are going to get this site that we're going to name K, and this side that we're going to name F. Well, to get these sides, we're going to make 2 right triangles. One right triangle right here, and other right triangle right here. And as you may guess, we have to find the hypotenuse of both right triangles in order that we can use the cosine rule, the cosine law, in order to find this angle. First, we have to get this hypotenuse, and we need, of course, the 2 other sides, this side and this side. We're going to name it C1 and C2. Okay? C1 could be expressed in terms of the cosine phi. So, as we may guess, we can cut this triangle until x, so that x is the hypotenuse, and we can find a relation with the cosine function, like cosine of A equal to this side from here to here, that we are going to name W over x, that is our hypotenuse. We can pass the x to the other side and leave W alone, so x cosine of A equal to W. And right now we have an expression that tells us the length of W, and as you may guess, C1 is W plus 7. So C1 equals to 7 plus x cosine of A. We have now one triangle, one side of our right triangle of the bottom part, but we have to find the other line, that is C2. To do this, we're going to make shorter our diagram. So we're going to subtract 4 feet to this side, so that we can forget about the height of the person. So 4 minus 4, feet plus 4 feet, it's like 0, and this equals to 6 feet. Once we have subtract 4 feet from our initial diagram, we get this with a total height of 28 meters, 22 plus 6, 28, and as you can see, we get away from the height of the person. So we can find an expression that tell us C2. C2 is this C2, and C1 we already found it, 7 plus x cosine of A. So C2 is the difference of this height minus 6. So we have to get an expression that tells us this height from this point to this point, and we can use the trick that we have already used of cosine, in this case sine function of the angle A, 25. So sine of A equal to this side, the opposite over hypotenuse, that is x. Opposite over hypotenuse. If we isolate O, we get x sine of A equals to the opposite, that is this side. And to get this part, we have to subtract 6 units, that is the length of this. So we get that C2, let me correct this, it's a little bit ugly. C2 equal to x sine of A minus 6, and that's how we get our both sides of our right triangle. So we can find an expression that tells us the length of K. So we apply the Pythagorean theorem. K squared equal to x sine of A minus 6 squared plus 7 plus x cosine of A squared, and that's how we get the length of K.
We have the other variable that is f. To get f, we need C3 and C1. We already have C1 that is equivalent to 7 plus x cosine of A, and that A is 25 degrees. So now to get C3, we need to get the height of this triangle, and we are going to get the height of this triangle by using sine of A equal to G, or opposite side, over x. When we substitute, we get x sine of A equal to G. So if this whole side is equal to 28, because we got the 22 plus the 6, then the formula to get f will be equal to f 7 plus x cosine of A plus C3 is going to be 28 minus G, that is G is equal to x sine of A to square root 2. That's this dividing. And we can, that is cosine of C. To take this cosine, we use minus cosine. That is multiplied by all of this, and we get C. And to get this value, all positives and this negative, you also multiply minus 1 plus this, and at the end it will be C equal to cosine minus 1 plus minus C plus A plus 2 divided by 2ab. Now substitute this, we got that c is equal to 22 is squared and is 484 minus 484 plus k squared plus f squared divided by 2 plus f and k.
Okay, now that we have the function that defines the value of c, that is theta, we introduce this formula into graphic calculator, and we get the value that maximizes the angle theta, in this case c. So when we introduce that, we get that maximum angle is 0.85 radians, and if we convert that to degrees, we have to multiply times 100 over pi. If we do so, we get 0.85 times 180 divided by p. We get that that angle equals to 48.70141 degrees, and that's the value that maximizes theta.
Second part of the project was to find a cosine curve that models the data. The problem that we solved was circadian rhythm. In order to solve this, first we need to know that y is equal to a cos k parenthesis t minus c parenthesis plus b, where each of these letters means days. With the data, we find that the amplitude is 0.4, the vertical shift is 37 that we obtain from sum the minimum and the maximum value and divide it by 2. Then C, what is the horizontal shift, is where the maximum value gets the C. Finally, K we find divided 2 pi, that is the period, by the maximum value, the position, where is the maximum value and the minimum, multiplied by 2. So simplifying, we find that K is equal to pi over 12. That in solved is like 0.2617. And then we find that with all these data, that the function that models the data is 0.4 cosine of 0.2617 t minus 16 plus 37. We put this function in a graph calculator. We obtain the best function sign that fits in the data is that y equals to 0.37 sin parenthesis 0.26 x minus 2.26 parenthesis plus 37. The team conclusion is that problems can appear in the life in many ways. The more we know, the better chance we'll have to solve them. In this project, we learn about inverse trigonometric functions, sinusoidal curves, and solution of right triangles, topics that are widely useful to solve application problems. Finally, it is important to say that this type of problems introduce us to a real world in which it's not enough to know all the formulas by heart. A process of critical thinking is required to analyze, interpret, and find creative solutions to solve problems.